In Lesson 3.5, students see a demonstration in which you put a tea light candle in isopropyl alcohol and in water. Students see that the candle floats in the water but sinks in the alcohol. The question is, why does that happen? You also do another demonstration in which you put water, oil, and isopropyl alcohol in a tall cylinder, like a graduated cylinder, and students see that the oil floats on the water but sinks in the alcohol. And the question is, why is that? The students are trying to figure out why it is that certain liquids are more or less dense than others. The main science concepts covered are that liquids have a characteristic density, that density equals mass over volume, and that the density of any substance is based on the mass, size, and arrangement of the atoms or molecules that it's made of. And if you compare equal volumes of liquid, the one with more mass is more dense. So after you show students that the candle sinks in the alcohol but floats in the water, you ask them, how could we measure or how could we compare the density of the alcohol in the water? So the idea is that if you compare equal volumes of liquids, the one that's heavier is more dense. So we use 50 milliliters of alcohol. This is isopropyl alcohol, a 70% solution, and 50 mils of water. And if you compare equal volumes, you'll see that the water weighs more. So since it has more mass and density is mass per unit volume, and you're comparing equal volumes, the water must be more dense. So then the question is, well, if alcohol is less dense than water, what about oil? So you ask students if they can calculate the density of the three liquids so that you can determine the density of each one and see if this stacking makes sense. So that's what students figure out how to do. They take the same volume of water, alcohol, and oil, and they get the mass of the graduated cylinder plus the liquid, a mass of the empty graduated cylinder. So then if they subtract the mass of the empty one from the mass of the one with the liquid, they get the mass of the liquid. If you know the mass of the liquid and you know its volume, you can figure out its density. So they calculate the density of water, alcohol, and oil, and they find out that it does make sense that water is the most dense, alcohol is the least, and oil is somewhere in between. And the question is, why is that on the molecular level? We'll take a look at water first. Water is made of hydrogen and oxygen, and it's pretty compact. The water molecules are very close together, even though they can move past each other. In oil, instead of being oxygen and hydrogen, it's carbon and hydrogen. Carbon is a little bit larger and a little bit lighter than oxygen, so it makes sense that oil is less dense than water. Now alcohol, instead of being like oil made of hydrogen and carbon, it's made of hydrogen and carbon and some oxygen. So you'd think that maybe alcohol would be a little more dense since oxygen is a little bit smaller than carbon and a little bit heavier, but alcohol molecules don't arrange themselves in a very compact way. So in the end, alcohol is actually less dense than oil. We also do an activity in which you can change the density of the water by adding something to it. So you can start off by asking kids whether a carrot is more or less dense than water and then showing them that it's more dense because it sinks. But is there any way we could get the carrot to float? We're not going to change the density of the carrot, but we could change the density of the water. And if we dissolve some salt in there, you can see that the carrot is starting slowly but surely to move up into the liquid. And if you put enough salt in, you can increase the density of the water enough that instead of sinking, the carrot floats. So we would ask students, when the carrot first sunk in the water, what was more dense, the carrot or the water? And now that the carrot floats, what's more dense, the carrot or the salt water? The salt water is more dense. The reason is because we added mass to the water without increasing its volume very much. So we increased the density of the water enough, so now the carrot floats. If you're in an NGSS state, the performance expectation MSPS 1.1 says develop models to describe the atomic composition of simple molecules and extended structures. In lesson 3.5, students look at the atomic composition of molecules such as oil, alcohol, and water, and try to make a determination about why one is more or less dense than the other. So density isn't particularly pointed out here in the performance expectation, but it's the context through which you can achieve the performance expectation. If you look at the foundation boxes, you can see that students develop models. They look at the atomic models, at the molecules that make up oil, water, and isopropyl alcohol. Under the disciplinary core ideas, substances are made from different types of atoms, which combine with one another in various ways. Kids see that's true by looking at the atoms that make up the three substances they're looking at. And also, they get the idea that each pure substance has a characteristic physical property, in this case, density. For scale, proportion, and quantity, it's the idea of looking all the way down into the molecular structure of a substance, in this case a liquid, to understand its macroscopic characteristics. Thanks for watching, and good luck with the lesson.